I'm going to go through the solutions to the last two t interval for mu examples in the notes. So hopefully you've had a chance to take a look at those. Example 3, this is the one where you're given a data set. It's like the ages of cars or something. The point estimate for the true average age is 6.9 years. The 90, what is this, 99%?
Yeah.
The 99% interval is generated this way. The important things to remember, the critical value here is not a z, it's a t-value because all we know is s. And I use Stata to get these summary stats, but you could use the ti or r or something like that. So I got 3.2498 using 9 degrees of freedom. Right, the degrees of freedom is always n minus 1. So this is what we get as our confidence interval. Assumptions, is x bar normal? Well, we don't know, right? We've got a small sample size and we don't know anything about the population. So what we're going to have to do is look at a QQ plot. Simple random sample, that was given, or at least I intended to give it to you. Sigma unknown, it's easy to assume you don't know something. Number 4, 3, this mu claim falls outside of our confidence interval, so no, it's not reasonable to think that the true average is 3 according to our results. And the MVD, the minimum verifiable difference, that would be 0.5983. So we think it's different from 3. How different do we think it is? Well, we think it's different by at least that much.
So with these ones that have like you have to look it up and everything, for n, couldn't you just count how many are there?
Yep.
Yeah, okay.
Did I miscount?
No, I was just...
Oh, okay. Yeah, n is just the number you have, so you could just count them.
Count, okay.
As far as normality goes, we need to think that it's reasonable to think that the population is normal in order for x bar to be normal because we have a small sample. And so this is what I got for the QQ plot. And I don't see any real systematic curvature here. So I don't think it's too unreasonable to think that the population is normal. So it's maybe not a huge leap of faith to do that. And so what I wrote for number 5 was QQ plot doesn't look too bad. So it may be reasonable to think that x bar is normal. Okay, any questions on that one? The next one, I actually gave you the data, the summary stats. So I'm sorry, I didn't give you the data, I gave you the summary stats. So this one, our point estimate from you is just x bar 19.3. I think, was the sample size 35?
Yeah.
So this critical value here is based off of 34 degrees of freedom. This is the interval we end up with. X bar normal, yeah, we're probably okay because of the central limit theorem. We have a large sample. Simple random sample, if it was given, I intended to give it to you. Maybe I need to rephrase that problem. The SRS is not going to be an issue on the exams and homeworks and stuff. That's not the point of this unit. Later on, we can talk more about that. Everything we're doing right now is based off of SRS, so that's what I'm going to try and give you. Sigma unknown, it's easy to assume you don't know something. 20 is actually within our confidence interval, so it is reasonable to think that the true mean is 20 because it's in our confidence interval. Any questions about either one of those two?